Welcome to part 3 of the anterior abdominal wall series. We are finally diving into those muscle and fascia layers in this video. So we're going to pick up from last time by returning to our external oblique. In the first and second videos, I explained how it contributes to the inguinal canal. In this video, we will see how it contributes to another structure called the rectus sheath. One of the things it does is contributes to this structure called the rectus sheath. So the white portion of this image around the umbilicus from here to the middle would be one external oblique with its tendon. So this external oblique has muscle around the outside, and then the tendinous portion is going towards the midline of the body. And that would be our tendon of our external oblique that we call an aponeurosis. So we're going to talk about it now using this word because that's the correct terminology. We see our muscle fibers here in a hands in pockets direction, which is down and in, inferio-medial, if you need the fancy terms. And then we can see its aponeurosis. And the aponeurosis of our external oblique is going to be one of three aponeuroses that contributes to what we call the rectus sheath. And the rectus sheath is going to encase what everyone knows as their abs, which is the rectus abdominis muscle, in a sheath, essentially. It's going to be locked up in there, totally covered. We're going to get to the rectus abdominis soon. But first, we're going to cover our oblique. So our external oblique muscles are our most superficial muscles in the anterior abdominal wall. So we're putting them into this picture as well. The first muscle we run into is our external oblique. Okay. And its aponeurosis. Now, just deep to this is our internal oblique. We might have some fascia in between because there's usually investing fascias in these areas. We're going to have an internal oblique underneath our external oblique, some investing fascia in between, and then we're going to have the last muscle here that is our transversus abdominis. From skin to deep, we are going skin, Camper's fascia, Scarpa's fascia, external oblique, internal oblique, transversus abdominis, and then two connective tissue layers. Oh my God. First connective tissue layer. This one you can actually see, like truly see. This layer of purple in our picture is the transversalis fascia. It's so difficult. I don't know why they put them right next to each other. Why not come up with a different name? Transversus abdominis is a muscle. Transversalis fascia is connective tissue. But you can absolutely see your transversalis fascia. It is separate from this transversus abdominis muscle and its aponeurosis because the external oblique, internal oblique, and transversus abdominis all have tendons, which we call aponeuroses. So the transversalis fascia is the next layer down. Underneath our transversalis fascia, and very hard to distinguish from transversalis fascia, but possible in theory, is parietal peritoneum, the internal lining of your abdominal cavity. The abdominal cavity is also known as the peritoneal cavity. Abdomen and peritoneum mean the same thing. And it is annoying because there's going to be a lot of perineum-ish words coming up. So we need to make sure we have them separate and we understand which is which. Peritoneum, abdomen. Perineum, that's where your genitals are. Different stuff. Very similar names. So parietal peritoneum, remember when we were in the thorax and we had parietal and visceral pleura, which were the layers surrounding our lungs? These, imagine them as the layers surrounding our whole abdominal cavity. We have a parietal layer and we're going to have a visceral layer. So we'll have a visceral layer, we'll have some space, some fluid, and let's say there's an organ right here, because this is where we find our organs. There is a layer of visceral peritoneum on the organs themselves. Just like the thorax, which is the body cavity, this body cavity is the abdomen, also known as the peritoneum. We are going to have a parietal peritoneum and a visceral peritoneum and some fluid between. And then we have the organ. So visceral peritoneum is on the organ. If I touch an organ in lab, I'm touching visceral peritoneum, whether I want to or not. If I touch sort of the outside body wall, I'm touching parietal peritoneum from the inside. And transversalis fascia is a layer just above the parietal peritoneum, separating it from our transversus abdominis muscle. All right, now we know our layers. Our external oblique muscle is first. I said it has a hands in pockets direction, and what we're going to do is we're going to cut out a little section of this and look at the differences in layers. So let's take a section, which is kind of what you do in lab, and let's blow it up over here and see our layers. We're going to peel them back. So the first layer we'd see would be our external oblique and its aponeurosis. So it has fibers going in a hands and pockets direction. And then it is becoming a tendon. So our external oblique, I'm going to repeat myself a lot. I don't care. Hands and pockets, fiber direction, most superficial. This is external oblique. Just in case people don't know, an oblique muscle is at a diagonal angle, muscle fiber direction wise, and that is why it's called an oblique. It has to do with anatomical planes from the very, very, very first lecture, or maybe an introductory lecture that you never got. The oblique is when it's off of a cardinal plane, so that means it is at an odd angle. So here's our external oblique. If we were to peel it off a little bit, the next layer we would see underneath it is an internal oblique. What's the difference between external and internal oblique? Fiber direction. Direction of the fibers. I'm actually going to make it red just so it's obvious. So while this one was hands and pockets direction, which is really inferior and medial, this one is going to be more up and in fiber direction. Not 100%, because the truth is it kind of fans out, but they're going to kind of go in equal opposite directions. So our internal oblique's fiber direction, I'm going to put fiber direction right over here. External is down and in. That's external. Internal oblique, we're going more up and in, equal and opposite direction, but it does fan out. So that's internal. And then last but not least, before we run into transversalis fascia, we have one more layer. Underneath our internal oblique is our transversus abdominis muscle. And just like the name suggests, its fibers run transversely. So it is going directly transverse. It's very similar in reality to the internal oblique fiber direction. However, it is much more transverse. So that would be our transversus abdominis. They all span this space between our costal margin and kind of the pubic pelvic bones. So they're going to have various attachments. I don't think we ever get into that for some reason. But this is the layers that you need to know. You need to know that external is most external and its fiber direction, internal is more middle, and then transversus abdominis is most internal. This is exactly like your intercostal muscles that you learned about with your externals, internals, and innermost. But this is just sort of the abdominal version of those with some slight differences. So to complete this picture, this is going directly transverse, which would be your transversus abdominis muscle. Knowing those layers are there and we are most superficial right now, I'm going to talk about the sheaths of the rectus abdominis, which is that muscle that I showed you using a piece of paper. It's on both sides. This is the one people think of when they think of abs, abdominal muscles. This is where you get your 6-pack or your 4-pack or your 2-pack or whatever, your no-pack. Just a straight line of abdominal muscles, which some people have. This rectus abdominis is encased inside of these aponeuroses of those three muscles we just discussed, the external oblique, internal oblique, and transversus abdominis muscles. Their aponeuroses surround this muscle, but they do it in different ways at different places. Kind of strange. So I'm going to explain it to you by using a cross section, and then I'm going to show it to you on here so you can see which layers are where. Because this is a confusing concept, and I really, really want it to make sense. So we're going to hemisect this abdomen here above umbilicus, and then here below umbilicus. And I'm going to show you the difference in how these aponeuroses, which go around the rectus abdominis muscle, coming from either side, are going to encase that rectus abdominis because there's a switch in where they are. So our upper cut above, this will be our above umbilicus, aka the belly button. This is our above umbilicus version. This is our below umbilicus version. This is the rectus abdominis. This muscle, but I've cut it and I'm looking at it this way. I know that's paper and it's hard to see. This is rectus abdominis, rectus abdominis, rectus abdominis. The abdominis just on either side. And then we have those three muscles. So I'm going to color code them. External is going to be red. So we got our muscle belly out here on either side. Muscle belly, belly of our external oblique. All right, so that's our external oblique in red. Here's our internal in blue, just beneath it. And then lastly, in orange, is our transversus abdominis muscle. The thick portion that I just drew is the muscle belly part. We are looking at it in cross-section, transverse cross-section. And now I'm going to draw in where the aponeuroses of these muscles actually go and how they surround the rectus abdominis. So our external obliques aponeuroses always goes in front. So this would be anterior or superficial. This would be deep. This is inside body, closer to internal organs, above or outside skin. This is superficial, deep, and I should separate them. So external oblique always goes in front of rectus abdominis. So the portion we saw covering the rectus abdominis from the front, part of it was made up of the external oblique aponeuroses. So these are those aponeuroses coming from both sides and joining in the middle. So that is above umbilicus, it does that. But I said it always does that. So it also does that below umbilicus. Internal oblique. What does it do? Internal oblique is unique above umbilicus. It splits into two. And half of it goes in front and half of it goes deep or behind and joins in the middle. Kind of cool. It's going to go around. So that's from one side and the other side would do the same. We have just encased our rectus abdominis muscle. When we are below the umbilicus, so that's above, I didn't put it, but this is below, the internal oblique aponeurosis does something different. It's all in front. So that's the first change. Something happened below umbilicus, right? We lost some back here. Now, transversus abdominis above umbilicus, its aponeurosis goes completely behind or deep to the rectus abdominis. So when we are above umbilicus, the rectus abdominis muscle is completely encased equally on the front and the back side. When we go below the umbilicus, the rectus abdominis is not very encased anymore because transversus abdominis also goes in front of rectus abdominis. When you go below the umbilicus, the rectus sheath is all in front of the rectus abdominis. Versus above umbilicus, it is on both sides, really encasing that muscle. So what is behind here below umbilicus? Well, I'm going to bring us back to this picture where we had transversalis fascia and parietal peritoneum. So behind or deep to my transversus abdominis muscle is always transversalis fascia. So transversalis fascia is back here. What else is back there? Well, parietal peritoneum, which I'm going to change its color to a lighter blue because we already have blue in this picture. But on that purple line, kind of really on it, would be parietal peritoneum. So there's some layers of connective tissue back there as well. When all of the aponeuroses go in front of superficial to my rectus abdominis, the only layers behind the rectus abdominis will be my transversalis fascia and the parietal peritoneum, which we can't really see with the naked eye. There is a point that you can see, typically from the inside. So you take your anterior abdominal wall off of your body and you look at the posterior aspect of it. If you could do that, you can do that in lab. If you could do that here, you will see the change. And the change is called the arcuate line. And that is when the transversus abdominis and that portion of the internal oblique aponeuroses switch from being behind the rectus abdominis to in front of the rectus abdominis, and you lose that sort of support back here. You can visually see that. And that visualization of that is called the arcuate line, where this change in covering occurs. You see it on the back side, the posterior aspect of the anterior abdominal wall. You will see the arcuate line. It will kind of arc on the back side. I'm going to show it to you as well. So what does that look like here is if I were to peel off my external oblique and its aponeuroses, and then I would also have to peel off my internal oblique and its aponeuroses above the umbilicus, above the arcuate line, if I peeled off both my external and my internal oblique, I would actually be able to see the rectus abdominis muscle. So if reflecting this portion of the external and then the internal oblique and their aponeuroses, and I've just done it up here, what would be left is I would see the muscle fibers and the aponeuroses of my transversus abdominis muscle, but its tendon, its aponeurosis goes behind the rectus abdominis up here. So I would see it disappear. I'd be able to see my rectus abdominis. But if I did the same thing down here, and let's say I peeled off more of those layers, so a bigger portion of those layers, then at this point, you'd still be seeing transversus abdominis and internal oblique, but I take it off in this picture, which in real life dissection, kind of impossible because the aponeuroses of our transversus abdominis and our internal oblique are actually fused here. So what I'm about to show is true, but also inaccurate. The internal oblique should stay in this picture and be attached to the aponeurosis of the transversus abdominis below the umbilicus as well. But its aponeuroses now switches, and the oblique's aponeurosis and its aponeurosis go in front of the rectus abdominis muscle. So this part would still be covered up because it is in front of the rectus abdominis, because this is the arcuate line where it switches. It used to be behind rectus abdominis, now it's in front of rectus abdominis, which from this view, from the external view looking in, seems like it would be more supported. But the reality is you just lost support on the back side, which turns out to be important in terms of hernias. This is why your hernias happen more in this area. One of the reasons why your hernias happen more down here. Hopefully that made sense. This is transversus abdominis aponeurosis, as well as the internal oblique's aponeurosis would also be in front here, and the external oblique's aponeurosis that would cover up this rectus abdominis muscle, which runs from your costal margin all the way down to your pubic tubercle. We're going to take a look at that muscle as well. Okay, so let's look at that rectus abdominis muscle. There'd be two rectus abdominis muscles, just like so. And I'm going to expose the rest of this one. I'm going to reflect the aponeurosis of the transversus abdominis to finally get and expose the rectus abdominis, which we already reflected the external oblique and the internal obliques aponeuroses in this scenario, so that we can see the whole thing. They're going to be bilateral. They're long muscles that span between your xiphoid process and costal margin to the pubic tubercle. And these muscles, as you can see here and here, are going to have these white connective tissue structures in between. As an important side note, when you look up rectus abdominis on Canva, why do all these images come up? Okay, back to it. Those are called tendinous intersections, and how many tendinous intersections you have is going to determine how many abs you have. So you'll see people with six packs. That means they have two bilateral tendinous intersections. Not everybody develops the same way. Some people have no tendinous intersections and their abs just like two long muscular sections with a line in the middle. Some people have only two, so one on each side. They're going to only be able to achieve a 4-pack, and then you have more and more and more, and you can have an 8-pack and a 6-pack and all these different possibilities. So you can have asymmetrical tendinous intersections like I do. So your abs will never look symmetrical, but you love them anyway because they're strong. So that is the deal with your tendinous intersections of your rectus abdominis muscle. This is how you achieve abs. Now, I will say a lot of people do a lot of crunches and stuff like that. And just as an aside, if you're doing crunches, you're really only getting the top portion, because the way to create these abs and make them contract is to bring your chest to your genitals. That's how you are contracting this muscle fully. So any movement that does that will create stronger recti abdominis. I don't know how to make that plural. That is rectus abdominis. You see this line in the middle of your rectus abdominis, and that line is called the linea alba. And I want to bring us back over to that picture we did earlier, because the linea alba is this point at which all of our aponeuroses come together. So it's just a thick portion of that rectus sheath, which is all of those aponeuroses of our external, internal, and transversus abdominis muscles. So that is our linea alba. Think Jessica Alba has nice abs, and when you see somebody with that very defined line down the middle going through their umbilicus, that is the linea alba. That is where all of those aponeuroses are coming together around the rectus abdominis muscle to create a indentation, essentially. So the linea alba is that midline sagittal line, longitudinal line down the middle of your abs. You have tendinous intersections that create the different amounts of six-pack you can have. And then along the sides of my rectus abdominis is another line. And that line is called the semilunar line. And the semilunar line, think half moon, because it's a little bit curved. Semi, half, lunar, moon. So this is the line on the outsides of my rectus abdominis. So those are our lines, and that's our rectus abdominis. As an aside, there is sometimes, in specific individuals, depends on the individual, there is sometimes a little muscle, almost like an accessory muscle, that attaches to the pubis as well, called the pyramidalis muscle. It's like a little extra ab at the bottom. Not a big deal, but it does sometimes exist, so I wanted to bring it up.
Thanks for watching. Don't forget to subscribe, and see you in part 4, where we actually look at the inguinal canal in a really short, quick video.